two notes on page 24. Question number 4 we're going to do together here. In the directions, it's talking about us drawing a line parallel to side BC through the opposite vertex. So with that being said, that's the hint that they gave us. With that being said, I'm going to go in and draw a line that's an auxiliary line through point A that's parallel to BC. And we generally draw our auxiliary lines dotted to indicate that they didn't really come with the question. And then in my proof, I want to put in there that my line segment, or line in this case, AD, is parallel to line segment BC. So I'm going to write, draw auxiliary line parallel to BC. And with that hint that they gave us about drawing that in, we're able to draw a couple of conclusions between the angles. So to give us a way to talk about the angles, I'm going to number the angles that are here as angles 1, 2, and 3. So one of the things that I know is that those 3 angles sit on a straight line. So I'm going to know that angle 1 plus angle 2 plus angle 3 is going to add to 180. And we've talked about this before, that when we notice that those 3 angles add to 180, we can say angles on a line add to 180. And then I'm going to go back and focus on those parallel lines. So with the parallel lines, which we mark with arrows on them, one of the transversals that I notice that happens to pass between them is this transversal. Some of you might find it a little easier if you sort of extend your parallel lines. So over here, I have that angle 1 and angle B are alternate interior angles, and I'm actually going to list them in my proof as being congruent. So angle 1 is congruent to angle B because of the parallel lines that make congruent alternate interior angles. So the alternate interior angles are there, but the fact that the lines are parallel makes them congruent to each other. And then I'm going to do the same thing over on the other side of the picture. So I still have my parallel lines, and this time, if I sort of extend them, I can see that this is the transversal that passes between the 2 parallel lines, and angle 3 and angle C are the alternate interior angles that will be congruent to each other. So in my proof, I'm going to put angle 3 is congruent to angle C for the exact same reason. The fact that the lines are parallel allows us to say that those alternate interior angles will be congruent. And some of you now, we've done enough of these in class, some of you now are probably at the point where you can sort of see already what it is that's going to happen. So in my proof, I can see that I'm supposed to say, as my proof line, according to what they say, that the angles inside the triangle add to 180. So in my particular picture, it's going to be that angle B plus angle 2 plus angle C has to add to 180. That's what they're asking me to prove, and that's what I've called the angles inside my triangle. And in the step that I have here, in step 2, I don't want to have an angle 1 here because angle 1 is outside the triangle. I want to have angle B. And you'll notice that angle 1 and angle B are equal to each other. So I can do this substitution for angle 1 and put angle B in its place. And then the same thing happens with angle 3. I don't want angle 3 really in my statement. I want angle C because that's the one that's in the triangle, so that essentially these 3 angles will end up being added to 180. So over here, in this sentence where I see the angle 3, I know angle 3 is equal to angle C, so I can take the 3 out and put C in its place. And we've done a lot of practice with substitution, so this should be something that you feel relatively comfortable with. So for number 4 here, line 4, I am going to put the same thing I have in line 2, but I'm going to put the substitution in. I'm going to put B in for angle 1, and I'm going to put C B in for angle 2 in a substitution. So angle B plus angle 2 plus angle C equals 180. All I did in this step was substitution, but it has allowed me to show that really the three angles inside the triangle add to 180.